another thin gold pressure vessel that we want to investigate is spherical tank. So let's write down spherical thin gold pressure vessel. So there are many applications. For example, in petroleum, if you search the spherical tank, you see there are many in here with the application for sphere. Or in wiki storage tank, and you can see that multiple for the petroleum, gas, etc. So that is multiple application, and that the purpose we invest the pressure and the stress on the tank with the spherical shape. So let's cut that spherical shape into two and investigate the free body diagram of one portion of that. So if we cut the sphere, so let me represent it here. And again, I exaggerate the thickness, make it bigger, the thickness of the sphere here. Might not really circle there, that is half of the sphere. And of course, when you cut it, it's exposed to the stress on the material make up the tank, as we did in cylindrical tank previously, and that we call that is sigma. In the spherical we call it 2 sigma, that is sigma hoop stress and longitudinal stress. This one simply we just put as P because the sphere is symmetrical in any directions. That's why we got only one in there. So from that one, it also exposes the inner pressure from the fluid. Inner pressure from the fluid to the goal of the tank. And again, we also call that pressure equal to P. So without any further clarification, we also know the A1, the area for the thickness of the tank, exactly the same as the one we have it in longitudinal stress, which is A1, and it A1 is equal to pi r outer square minus pi r inner square, and after transformation we did previously, it will be equal to pi 2RIT plus p t square. So let's write down here the A1 is exactly the same of that scenario. So we have that equal to pi 2RIT plus pi t square. And similarly, we have the area for the inner pressure A2 is equal to pi RI square. And we can apply the equilibrium the same as we did before. So we use equilibrium. And sum of all the force equal to 0. So we have it 0 equal to sigma SP in any direction that you have times the area 1 minus P A2. And of course we do exactly the same on the longitudinal stress, as you can see with the equilibrium we have and transformation. And we have that is equal to sigma of the sphere equal to P A2 over A1, and it also equal to P pi AI square over 2 pi 2AIT plus 5T squared. And yes, exactly two these scenarios, as you can see, and from that we approximate because the t very small compared to the inner radius, we have the sigma longitudinal along the longitudinal axis pi over 2t, same equation, so we can have exactly the same for the sigma of sphere. It also pi over 2t, and it actually it's same as the sigma longitudinal axis for the cylindrical tank, so that we can put it in here. So as you can see, at any direction, sphere have the stress on the tank is on the material is only pi over 2t. But if make up with the cylindrical shape, the maximum stress that have is pi over t, which is the Hooke stress, pi over t. For sphere, it only half of that, pi over 2t. So for that reason, talk about the talk about the thickness required for sphere with the same inner pressure. The sphere will require less thickness, so which means less material compared to cylindrical shape. But the question becomes, so why people still design spherical shape? You may consider that this one is much easier to fabricate. Cylindrical tank easier to fabricate compared to the one that I just showed you with the sphere shape. As you can see, it more difficult to fabricate and manufacture. For that reason, that why both it still exists and in the real life. And from that, let's go to the same as previously. We determine the state of stress and the Morse circle for the spherical tank. State of stress represented by a square block, and in this case, in any direction, we have it sigma sp, spherical stress. So we can have in any direction, which is sigma sphere, and it actually is same as the longitudinal stress on the cylindrical tank in any direction and all in tension. So this one also sigma sphere equal to the sigma along the longitudinal axis in cylindrical tank, and the magnitude equal to pi over 2t. And also we can be able to draw the Morse circle for this situation, and it's very special as you are going to see. So for sphere, we have the x-axis, which represents sigma, and the vertical axis, it represents the tau. And as you can see, for sphere, only 1 point, because both x and y component are or 1 and 2 are sphere. So what does that mean? Sigma 1 also equal to sigma 2 equal to sigma sp and equal to sigma L. So it only has 1 point. So that is the Morse circle, very simple. Sphere at that 1 point equal to sigma L. What does that mean? The Morse circle only 1 point instead of have a radius. It means that we have no in plane shear stress. For the sphere, and that's why the ideal for the design is for the pressure tank you design the spherical shape. But like I say, it compromise with the difficulty of fabricating, producing this type of shape. So with that, we done for the single pressure vessel. We go ahead to practice worksheet 14A, B, and C before we go to the next topic for today's class, which is prismatic beam design.